So, all right, we're going to talk about duplicates, duplicate array problems in JavaScript. So, specifically, we're going to talk about one of the easier versions of this, but the solution we're going to use is going to be much more universal. And you can use it for a lot more things than just these duplicate array problems. So, our problem description asks us to write a function called hasDuplicates, and we have this stubbed out version right here. And it accepts a variable number of integer arguments. So we have it being used right here, and we see that it accepts a variable number of arguments, meaning some of these have more of these arguments than others, and that's okay. So we want to accept that as our input, and we want to return a Boolean. Specifically, we return true if there are duplicates in the arguments. So in this case, these are just our little mock tests. We're saying it equals false because these are all unique values. So okay, that makes sense. This one, it should also be false, as in false, there are no duplicates, because these are all unique values here. And then here, true, we say we have duplicates because we have 2 6s. Here we say true because we have 3 1s. If you're not familiar with this syntax here, this is essentially a good way to accept variable arguments in JavaScript. It uses something called the spread operator, which you can find more about by just looking at the Mozilla docs or something. Google spread operator MDN or something like that. But essentially, we're just going to spread out these values. We're going to spread an iterable object, and we're going to make it into an array. So that's a lot of talk. It's a lot easier, and probably would be more satisfying if I did something like this and ran that in this little node environment we're running. And we see that we have an array right here, just what we passed in. So that's all that's doing. And now we'll implement our solution. And specifically, we want to do it in linear time, big O of n, or better. And we could get from linear to linearitmic, or log of n time, but we're not going to do that here. We're just going to talk about this solution, which is better than the naive solution, which is quadratic time, or big O of n squared, quadratic. And the way we would do that is, or most people would probably go about it by saying, okay, let's initialize a variable I, assign it to 0. Let's say, well, I is less than the length of that args array. Add to it. And then you would put another loop in there where you say for let j equals 0. Oops. Sorry, not used to this keyboard. Well, j is less than, you could say args.length. We say j, not capital, regular, j++. And then we would essentially just do a check here so that when we have this first item, if we have an array like the one we got passed, the one that was passed in from our test case down here, then we would start at 1, and then we would check everything here, and then we'd start at 2, and the way we currently have it, we would check everything again, but we don't need to check anything past or before that I variable, so we could optimize a little bit by just saying, j equals I, but essentially we're still dependent, we're still doing nested looping. So for every n item we have in this array, we're going to do an operation n times. So that's how you get the square. So if we have, 5 items or however many we have, 6, we're going to do, we're going to start here, then we're going to loop over everything, we're going to move here, we're going to loop over everything, etc. Anyway, that's the naive solution. It makes a lot of sense because it's very imperative. You're kind of doing things step by step. We're just going to do it a little bit differently. We're going to do it by implementing a frequency counter, even though it's not really a frequency counter. So this is that super versatile technique that I go over in another video. Check it out if you haven't. but it's essentially where you create an object or a map of values, of key value pairs, and you would put, in our case, for example, you would our key would be a number, so it would be 1, and then we would just put how many times it occurs in this frequency counter pattern proper. But in our case, we're just going to say true, because we just want to know, is it there or is it not there? And we want to put it somewhere where we can access it immediately, and or not immediately, but in constant time. So in a consistent time, a time that's not based on, for example, length of an array. We can access from a map as fast as the computer can do that operation, essentially. So we'll actually use a map here, because I think it's a little cleaner to read. But then we'll also solve it with an object to show you that it's really not that much different. So if we have a map, we want to, well, first what we want to do is iterate over our args, because we need to evaluate these. We can't get around evaluating these. And we'll do it linearly by saying, for, let's call it num of args. For every number in there, we want to push it to our map. So we want to check if it's in our map first. So m.has that number. So if that map has that number as a key, then early return. Return true, because we know it has duplicates. Because what we're going to do next is push it to the map, m.set. And we're going to set our number to be our key, like we talked about here, and we're just going to push that boolean, like we talked about here. So we're just going to check this, if m.has a number, and that's going to return true or undefined, which is fine in JavaScript. We're going to return true because we know we have duplicates. Otherwise, we're going to push it to our map. And then at the very end, this is our worst case in terms of time complexity, meaning we've gone through every item in the map, or every item in the args array, and then we've pushed it to a map. In this worst case, we'll just return false, because we know it doesn't have any duplicates. And so let's try to run our test case that was false before, and we get true. So it looks like it's working. We'll uncomment the rest of our test cases and run those, and we get a lot of trues. True, 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 true. So those all are working as expected.